He's an author of one of the most amazing contemporary buildings.
You can have it.
Is it better like that? Oh, yeah, it's much better. So Mario Manotti, he's an author of one of the most amazing contemporary buildings, but he's not an architect. He's a structural engineer, and he works with probably the most outstanding contemporary architects. And in his buildings, structure every time becomes actually architecture. And it's very interesting to see this migration, or like how he merges structural approach and architectural approach. And he is actually in charge of making our architectural concepts look for the structural stability, for reliability of the buildings. He makes them elegant and beautiful, everything what we're aiming for, and I hope tonight it will be a bit more clear to us how to do it. So Mario Manotti, he studied in Zurich at ETH. Over there he wrote his PhD, and then he moved a bit to the south, to Italian part of Switzerland, and in Locarno found his own office. Probably I don't have a right to occupy this stage anymore, and please welcome Mario Manotti.
So, guten Abend. Ich rede auch Deutsch, aber ich werde auf Englisch diese Unterricht halten. Ist eine Besprechung eigentlich. Es freut mich sehr, zwischen euch zu sein, da in Wien. Ich war heute Morgen in Mendrisio und eben zwischen zwei Universitäten, so ein Tag, es ist wirklich extrem schön. I choose this title, Technology of Support or Difficulty for the Construction. And in this title, of course, I will speak with project. It's not philosophy, but you know, I want to put attention on one thing that we always forgot when we do a project. We always speak about material, about space, about many things. But at the end, building is a work, and it's done by people. And we have to take care that people feel well by doing this work. I think it's our responsibility. As it's only one thing, so when I teach in the school, I have to teach things that are old, that are clear. Static is, it's clear how to do that. When I work in the office, I just do my calculation. But when I go at the exterior, I like to look forward and just to try to improve our work a bit. Okay, let's start. If I can explain that a bit, I don't know. I want to start with basic tools of design. What are, for me, the basic tools? And I decided to start by presenting you my house, because if you see that, then you know myself a bit better, and you just know what is important for me. It's one house that I'm an engineer, as we say. I developed it with Atelier Scheidegger-Keller. We will see some project of this atelier. I live in Gordola. Gordola is part of Switzerland, in the south, Ticino. I speak Italian. And you see the river. This is the Verzasca. If you continue on this direction, you will find this dam where James Bond was springing. I'm really close to, it's one of the first house if you just follow the water. This is it's already a nice reason to live there. You see the landscape is really deep. And there is a tradition of wine. And you see in this, I just take one picture over the town. It's still like that. You see how you use the land. And there is my house. you see, is exactly the same. Though I live in a slope, and to make it, to use it, I just built terrace. Part of it are interior, and part are exterior. And there are staircase, and you just go continuously from one level to the other. This is the bottom level, and there is a second level, which is exactly the same. You see, I don't like to make calculation. If you do 2 times the same, it's more simple. But the trick, there was a joke, how you can cut eine Küche, with 3, you just use 3 times the 3 cut, and you have to have 8 pieces. They have to be the same portion. Then you just do 1, 2, and the last one you just make it horizontal. And this is a bit the same, because if you cut it in horizontal, you will see that everything starts a bit to change. There is a roof which gives to the upper level a different ceiling, and there is the floor that are going down and down, which give to the lower part of the house a different atmosphere. And then when you see from this wall, which are related from the exterior, which, of course, where there is the windows, we have to an orthogonal angle, but then there is angles that are not orthogonal, then you receive space that are all different, completely different. Okay, and now go back to the basic tools. As an engineer, I like forces. I like balance. Forces have a feeling. We feel as men the forces. Forces are amazing, and if you try to work with forces, it comes to balance. And you see, these are my daughter. They are fascinating of this vertical wall. Vertical line, horizontal line are really strong. For my house, I choose a vertical one because it's less obvious. The horizontal one is more common. It's what you see, it's what you expect, and to say, let's try with a vertical one. And you already see how impressive it can be, a vertical cut in the earth. That was the beginning. Then, of course, there are materials. I like this image because you see how this house was building. We just used the material in place, quite a lot of stone, you will see it after, and we transform it, you know, just to do the house in the same place and to transform it and to make order. It's a nice thing. So we say force, balance, materials, and then geometry. Now you can start to see when you go around on this wall, you will find different dimension. Now it's an architectural geometry, but when you do a structure, there is a lot of geometry. And have a feeling of geometry, it means to do a nice structure. And then another thing that for me it's really important is the construction process and the imprint of craftsmen. I think it's really important to preserve that, and that is go beyond of the materials, go beyond. Just to see all the work in the construction is something that makes the construction rich. And you see this, Luca was cutting and do all the formwork in a traditional way. And then, yeah, you see, this is my work, basically. These are the formwork. You know, if you come in the evening, you are tired, you put one hand, you can just follow, and one time you go to the bed. Then I say, okay, if it's like that, I just turn off all the house, and these are the formwork. And then we just go in deeper. I I just draw the formwork, the step. You know, with this traditional formwork, you cannot put concrete too high. Then there is some joint between slab and walls, just to make it disappear. I wanted to show to my children the construction as it is, and to put no things. Then I spend my time to take things away and not to add. And then you just see, this is the reinforcement with all the technical installation at the interior of the concrete. And there you already see a bit of results. You know, you see in this staircase, the formwork that go to the end. You see the walls. You see the staircase, which is built between walls. This is the interior. You see the different level. It's always the same concrete. It's a building space. It's really robust. And you see the geometry and the light that take part and make games in this space, how nice it is. And let's go one step further. This is Christian Scheidecker. You see this staircase. And let's get one back. And you see that it continues at the exterior. This is also nice. And this is from the exterior. You see, there are the stone. The concrete is only for, it's a special thing for myself and not for the other. I just put it at the interior. Great. This was the basic tools. These are the things that I want to put in all the projects that I do. And these are the things that I want to try to do in a different way in the future. Just use technology. Of course, basic tools alone are not enough. We need a strategy how to do building. And the first strategy is to divide things in portions. This is something that is part of the engineering thinking, to divide things in portions just to make it clear, to take a decision. And I will speak about this idea, this problematics. It's not a building. It's something that I built for the Venice Architecture Biennale 2016. That was the participation of Bahrain. And this is the second architect, which I just choose these two project of these two architects to show you. That is an Oltrop. I'm sure you know him a bit. It was the project. Something really simple in aluminum, an aluminum frame. This was the topic of the Biennale, this in 2016. And this was the plan and view. And it's quite big, 140 square meter. And then, as every structure, you just need to be sure that it doesn't collapse, that it works, even if it's quite light and quite simple. Nevertheless, it's good to pay attention. I do a statical model. I do a calculation, and then I receive results. Quite complex, you know. I'm sure you have some lecture in structure. You know that a structure, to stay rigid, have internal normal forces, shear forces in two directions, then bending in two directions and torsion. And this is all the kind of forces that I receive. And then I just say, okay, if I want to make it simple, I have to divide it in a way that I eliminated difficult joint. And I just look a bit in the wood, what you find. And the most simple joint is working in bending and shear. If you have torsion, it becomes more complex. If you have bending in two directions, you are almost lost. And then I just go into my structure. I just start to divide it. And you see by the color, I just try to avoid two broke nodes, because these are really complex. And you just see the results. I just get the structure, which is carrying the loads only with bending, without any torsion moment, or torsional moment only at the interior of elements, but not between elements, and no bending in the second direction. And in this form, we just built pieces. So this is divide things into pieces in an intelligent way. And then you see how we do that. The aluminum, you get warm, and then you just put aluminum in the shape. This is a panel for the floor, and this is a frame of this structure. And there you see this construction, and you see the nodes, which just is reduced to only with one plate and one piece of steel, really thin. It just disappears. You know, I just really think if you want to make a nice project, you have to be able to reduce things to make it disappear. And this was the construction. It stay. Then we have to divide things in portion just to understand it. And the second things, we have to put it together in a way that we create one unit. This is really important. Just try to create one unit by the building process. And I will to speak about that with a completely different project, which is a residence for students in Zurich. And a project is a project that I did this time with Atelier Schedeger Keller. And it's only the facade. If you go in Zurich, this is the building. And look at this facade. This is what we want to speak. I just show you this building in the plan. It looks simple, but it's not that simple because it's not straight. There is a light curve. Then many windows. You see this double high. And then we have place where you can make grill. It's for student. They have a common space, a common terrace where they can make fire. And then there are pieces that are coming out. This. It's quite complex. It's quite complex if you want to build it in brick. And this is how you do brick facade. You see there is the insulation, the windows, everything. And then this is the waterproof. And then there is some space in between. And then we have the brick, which is carrying the loads vertically. And so it's a structure, but it's not stable, and give horizontal forces with anchor to the structure which is in the back. But because they wanted to make it cheaper, they just did a skeleton. Then there was no matter to put this anchor. We just built a wood structure to carry these loads, even because in Zurich they use 20 centimeter or even more insulation, and it became really difficult to put this anchor. And last things, there is this horizontal piece of steel, which are truss. They are completed with the mortar. If you put some compression, then you see that it's an horizontal truss, which is carrying the loads to the anchor back to the facade, and then you just get the stability of the wall. Great. We want to build with these pieces of facade. And the discussion that we had was this one. By the lintel, if we want to make it conventional, we saw concrete structure, which is covered with Klinkremrinchen, are this piece of cutting brick, or just to steel lintel. And I just say, if it's light curved, the structure, you can do whatever you do. This will never fit to the facade, will never give one unit. On the other hand, you can say, this piece of steel is a piece of steel, maybe it's not so interesting. And then I just say, okay, let's try to work a bit out with this piece of steel and just see what we can reach with them. And then you see we just built the wall. We just continue around windows with really simple standard profile. And then we just go to the end where there is this curve. You cannot do a profile that go from stone to stone like this one. You see that this stone is a bit higher. It's not stable. And I say, okay, let's continue over all the facade, all around. If you give many support, it just becomes stable. And it's really simple. You see there the situation. And then the angle. This is an angle, square angle of two windows. And you see the two windows. And the stone have to fly. And this support can work. We just have to cut it to piece together and hanging in the middle point. And then we can continue to put the stone, the brick, one after the other in a standard way. And that's create one unit. No? And then now we start to make a bit game. Okay, there is the entrances, but we have the steel. Let's try to do the steel a bit longer. You know, then it becomes part of the structure of the construction, and just show how things are built, and everything become one unit. Of course, this is a piece of steel. Usually we just cover the steel with the brick, and there are other entrances where the piece of steel is covered, and there is a box with brick. This is the part which fly, that go. It's the same thing, just a bit more stronger. It's not a piece of steel; it's a beam. This are the balcony. We just add to the vertical part a beam or flat element. There we just connect the horizontal reinforcement of the brick, and we get rid of the problem. But for the one who is doing the work, it's always the same things. You just have to put stone one after the other, and he can follow the curve of the building, and we never see a different situation. It becomes just more rich. And this is the fireplace. You see, we just use brick. We just shift it a bit on the left, and we just give a support. And these are the different level. And this is a bit the results. And it's something that is stay in the facade. You know, if you build in a natural way, at the end your eye will recognize that. Great. Right, now I want to go a bit further. This was a bit tradition. It's what we now have to improve and to take it into something which is more close to our time, to the technology. And I want to speak a bit about the mechanized construction. That is the prefabrication. Let's start with a project where I discovered the prefabrication and how I discovered the prefabrication. It's a project that I did with Atelier Schedeger-Keller. We are in Willen. Willen is a small town, really small, close to Lucerne. Maybe this is Lucerne. There is this amazing hall of Jean Nouvel. Thank you. This roof, amazing roof. And this project come from the calculation model and from the construction. You know, now we are going back to the further basic tools, and we give a new vision. This is the place. And if we give a look, no, there. This is the house. We see it a bit. It's one space. It's really similar to my house at the end, because you see in horizontal, there is the lake, you see, and then there are different levels. These different levels are coming into the house and defining the space. In this, underneath this roof, which have 220 square meter, 90 square meter is the interior, 45, 50 are this part, and half and half are the room, the bedroom, and the kitchen, which is over there. And by building only one roof, you see not only the landscape that come horizontal into the house, you also see the mountain which go down into the lake. And this is a unique situation. But I don't want to speak about that. Of course, I want to speak about structure. And it was not so easy to build this roof, because when you do calculation, you know, you can make a calculation of a slab, of a wall, of a column, of a three-dimensional structure with linear elements. But to put planes which are not flat but have an inclination and take the forces and follow the forces into two columns, it's not easy to do. And then I just produced this model. I just continue the column into the roof by dividing pieces and by producing a truss, a three-dimensional truss, really simple. Then you can do simplified analysis. You can design better the elements, and you are more close to the building process. Of course, of this model, Christian built his own model of the structure, and then it was clear that the blue part have to be built and can carry the part which wasn't there, and then we study different solutions. Let's put wood, steel, but we say, okay, we stay by concrete. And this is a bit the model in wood, just to see a bit better how it look like. You even see the thermal cut between interior and exterior. And then we just do the formwork, and it comes a construction problem. You know, you cannot build a nice building if you don't know how to build it. And if you use concrete, concrete is not is fluid. And if you have to put concrete in a slope over this high, it just fell down. And then one idea, let's complete the panel, this panel that comes from the calculation, with a vertical element in order to produce by the formwork, by this lost formwork, with the precasted element, produce the beam that we will put it in place and in a standard form. You know, we already receive a closed geometry, really simple to build. And so there are our precasted element, which come from the calculation and which are on incredible help for the people that have to build, which causes everything become really simple and really precise. For this construction, it was really important to have something precise. And there you see the construction step. This is the support. Then we put the formwork, also this, these precasted elements. We close it the space in between, just to create these beams. And then we have, this is the reinforcement. We put it there. Pay attention to this element. I will tell something after. We was incredibly happy when we get it. There was even a big problem. You see this steel? He forgot to put this steel, and then it was terrible. And then we just solved it with a cable, a cable of a steel cable. We just put it after in a different way, and we become friends at the end. And then you see the exterior piece, which is cut it. It's completely independent, and connected to the interior one with this, which are steel beams, a bit curved, with some insulation. And then this is the exterior part that we build it after. And you see this amazing roof, which from many pieces become only one. Just get it together. And you see this is a view of the living room. You see the promenade, you see the lake, you see a bit the mountain. This is from the kitchen. Give a look. The mountain disappeared. I just let it a bit. The sea is not so big, but when you are in the kitchen, it's like to be at the sea. And when you go down in the bedroom, you just see the mountain, and then you have a different atmosphere. You see this piece? Let's go back to this image. This is symmetrical, this support. This one is a bit asymmetrical. When you put a roof, a symmetrical roof, on 4 points, and the roof is symmetrical, the forces just split in 4 parts, which are similar. But now let's try to carry the same forces, which one hand like that, or one hand like that. This one just go down. And if you have a roof and you just let one element go a bit down, it starts to shift. At the beginning, this pillar was a bit more close to the center. But during the construction, Christian said to me, "Can I move you a little bit?" Yes, of course, let's move it. But then, when I redo the calculation, I was really saying, "Oh no, it's not possible because we just move it for that much." But the movement that you receive on the windows and the horizontal movement are incredibly high. We are speaking for 4 or 5 centimeters. And then Christian started to go and visit kitchen with the client, just to give the time to solve the problem. And this element was first things, the element that you show is a press stress in these pillars. I press stress the pillar just to give the forces and to correct it a bit, but it wasn't enough because I could correct the dead load, but I didn't have enough tools to correct the snow that come and go, and then the windows just get cut. And then I just say, okay, I simulated the snow with this cable. I just push the roof down, so that when it comes the snow, when it comes the loads, they just give a bit the force back, and the roof doesn't move horizontal. And after the construction, I just make measure, and I just let it one. At the beginning, it was one pro each corner. Now, there are 2 pillars and 1 cable on the back. But nobody see that. OK, and this is the house. You see it. It's amazing. I can tell you, when you go there, it's a small, it's only 90 square meters, but it's incredibly rich. OK, let's go to another project. I want to speak about geometry and joint. If you do precast, you cannot avoid the joint, no? But it's just how to accept, how to look at the joint. This is important. I have the opportunity, and I speak with about a project that I do with Studio Anne Oltrop, with Sam Oltrop. Was my first project with Anne Oltrop. It's the National Pavilion of the Kingdom of Bahrain for Expo 2015 in Milan. And after Milan, go back to Bahrain. This building was moved from Italy to Bahrain. And so we shifted 2,000 square meter building in concrete on one continent. I think never happens. But we didn't realize at the beginning. This was the plot. This is Expo Milan 2015. And this was the plot of the state of Bahrain. And the idea of this pavilion, I don't know if you visit that or if you know this pavilion a bit, but you will see it. Basically, what is a national exposition? You have to try to take the characteristic of one place into another one. And just look at the shape and the landscape and try to redraw it, reinterpret it with line and circle. And then just receive, if you put on this plot this idea, you just receive such a drawing. And then you have to try to give to the people that visit this building the impression to be in Bahrain. And then you have to put everything you can, the color, the smell. And this you can do with trees, you know. And then this, you see the project become more rich because you just start to take place away and put some green space with trees, and then there is a walk that you can do from one door to the other or coming back. It starts to work. And then, of course, this was a bit my part, the construction. This kind of material, the stone. Let's try to build it dry, to put stone together. Not all stone, we wouldn't take stone from Bahrain, put it into Milan, and then back to Bahrain. It was a bit too much. Use stone from Milan, and let's try with precast concrete construction and see what happens. And we start to make an engineering of this project. This is the tessellation. It's something really nice in mathematics. The shape, how can you put shape together? How, which combination are possible? You discover that not every combination are possible in nature, which give you some advice about structure, but this is not the topic of today. We have, it's a production tessellation, you know, what you can do with a certain amount of money really engineering. Flat line, you can do whatever you want, big, small. You just have to pay attention that you can carry the elements. Curved line are a bit more difficult because if you make a curved wall, you need all this kind of formwork, which is really expensive. And then you cannot have all the possibility. We just reduce it to 7, but we let the opening free. We let the angle of the element free between, depending of the size of the formwork. You see it stay on this vibration table that give us a bit of dimension. And then you see a bit the transformation of the project. This of the beginning, and this was after some months of work. They are quite, you see this element, this area, it become a bit more less large, because otherwise we cannot transport it anymore. Or from all this angle, you see that we reduce it to this criteria. Okay, and now speak about connection. This is what you do usually. Usually you just start to work with steel. You don't do connection with concrete. It's really difficult. And this was the first draw that I saw when I start to work on the project. And then I say to him, look, I think we can just put things together and we can transfer bending. This was the image of the discussion that we have. I say to him, with a piece of steel, I can transfer bending from from one element to the other, which means I can connect in a rigid form elements in the same way as we saw on this aluminum frame that I show you at the beginning. Then it was how you put this stiff element between two pieces of concrete. You needed to have it on one side and then stack it out. Not so easy, but we just believed that this could be a solution, and we even drew it and tried to understand if it was possible. And then we just put, we studied a cross-section of this pavilion, and we say, okay, let's cut it in a simple form with axis. And then we discover, oh, the geometry become really complex because this wall, this support, which are these appear and disappear, are really difficult. And then you lost this space, this technical space. And then, okay, you can fix the wall. The floor, you have it there. We put the same details there just to understand. And we work a lot on that. And then we try to simplify. We get rid of this support. We just put steel support. We get rid of this, and we just make independent support. And we just realized that the connection that we study was good for the wall. Cut the wall in two pieces. It's important because you can build only small pieces, or you can build a long element, divide it into pieces, because you go from 4 meters into two pieces of 2 meters, which is really important for the transport, and for the transport in Italy, but also for the transport out of Italy. And you see this connection doing by the wall, by the construction. We just put the steel on one side. We let one open. We put some concrete on it, and we close it perfectly, and it was stiff. And then we work out these details, and we get one idea. Why we just, if we cannot move it, we just let it open, you know. We just let these details open to the top. We just put it from the bottom, but then it doesn't work because You don't have the forces. And at the end, we get one idea. We just use a piece of slab as a beam. We reduce the thickness, and we just support pieces of the roof on this element. You see it better there. This is working as a beam, and the rest is in equilibrium over the other, just in a puzzle, in a three-dimensional puzzle. And so this is the design we try. We design it just to see if we have enough space, because we didn't want to increase too much the thickness of the elements. And there you see the final draw. We get rid of the steel. We just work with brick. We have some foundation, the floor elements, the walls divided in two, and then the floor with this connection. And we produce all the panel, and then we put it together. You see the foundation with the wall. This is the drawing. Then the floor elements. This was this part that I show you. There. Yes, there. Then we put the second part of the wall with this connection. And then, hopla, the roof, and you see this kind of joint. And there we see that this puzzle just get together without any screw. And the joint become the nice part of the building. And this is from the top. And then was quite terrible. When you finish a building and you are really tired, to see that again on your table, it's quite terrible. Then we take it apart. We cut the steel, and we put a plain steel, because we didn't have so much space between the two walls. And then we put it together again, and this time it's in Bahrain. And you see how nice is it, how it fit in the original place. You never think that this building was coming out of an expo. Material. This was also a nice, incredible, nice experience that I make with an Ultrop. We wanted to build a souk. This is one project that we start exactly after the expo in Milan. We are in the old city of Murat, in Bahrain, and we received this plot, this old souk, to make it new, and draw a really simple plan, really simple, because the idea was to make it in stone. And then we just try to, okay, this is not good, don't do a circle if you do one arch. It's a parabola or a catenario, but not one arch. And then we try to correct it and put some loads on it, and then we cut and we get this shape. And with some work, we get into this shape, which corresponds to this souk. You see how it is. It's really simple. You have the different market. You just get in on the street. Then there is another street on the back. You have a different level. And you have the opportunity to do two level somewhere, just to make it a bit more rich. And then we say, as usually, let's try to build one piece. We take a piece of this, and basically, these are my drawing. You see that in plan, the foundation, the elevation, section A. These are the roof. With the stone, this is the section B. It's just 3 walls and a roof, a piece of a roof. I just try to work with stone and some connection in steel, just to put it together. And they, in Egypt, they just cut this stone. They were surprised. They say it was a few years that they didn't do this job. And they was really surprised to do that again. You see the stone, and then we build it. You see the steel that puts the elements together, just a bit high-tech. When we saw that, we didn't like it anymore. Because from the stone, there was no things. If you look it carefully, these stones are that much of work that they lost a bit of identity. And then, and so this element, this is how you use stone. And then we go back and we just say, okay, we believe on that, and we build our own stone with prefabrication, and we just build piece of wall, but we let the end a bit free, exactly like this element, which are just cut it, really control it, but they have one end, which is the stone, and we just cut it the end by using sand casting. We use sand to put in the formwork. And you see the stone. And we build this souk. You see the stone, one over the other, really thick. We could do that because it was in Bahrain. We didn't have to ship from Egypt to Bahrain. And you see it. And now you feel the stone. I never have, for COVID, I never have the chance to see that personally, but I believe that you need a few seconds to go to the interior and to see this stone, these amazing pieces, to feel how big they are. And this is the real material, you know, at the end. It's not if you use the stone, the feeling of the stone is much important than the material, the original material itself. Okay. I want to go to, you see, I just use all the tools, the basic tools that I put in at the beginning in a project. I just want to go to balance. There we just cut a bit the stone. But if you start to work with and cut element, you will receive element of this shape. Try to get it in balance in a building. They cannot stay, yeah? But if you put it together, they start to work, and the one is falling on the left, the other on the right, and they just work together. And they can start to become, this is half of a building together. They are in balance. Then you see the forces. On this project, you see the formwork, really precise, the elements. It cannot stay alone, but in a building it works. Then you see the game of the forces. It's something that you receive in this project. You see all the different stones that we produce, all the different elements, and you see this project, this amazing project, which is some rooms of a guest house between old and new renovation, and this is the new part. Okay. This is, for me, the most important things. Just to make a work for people, and to create an identity or craftsmanship. And I do that with an old trope again in the green corner building. I don't know if you know, the image that I sent it for this lecture is of this building. Let's try what we didn't try before. Let's try to change the surface of the stone that we want to make it free. Not the border, not the shape, but one face. Now we do one face is concrete over sand. It seems really simple. This is the building, again, really simple. It's a staircase in the middle, 2 rooms, one on the left, one on the right. There are only 3 facades. The last facade is in the back. It's a standard facade because there, on this plot, I don't know if you know the work of Christian Keretz. if you know this parking that he is building in Bahrain, one of these, R4 parking, is exactly there. And I was involved in, I'm involved in the construction of the parking, and I want to make sure that this parking was stable. And for this reason, you see, I already let some connection point on this wall, just to give it to the building close to this, which have only pillars, and this is a problem. Okay, maybe with a bit color, you understand a bit better the elements and the windows, and the typology of the elements. It's simple, but when you start to let the surface free, you get loss of one of the most important things for engineering. You don't know the weight anymore. If you let people do the shape, how you can manage that, I just give a rule. I wanted to let people free, but I wanted also to do my calculation. I just say, okay, we do a box. 20 centimeter, this is a vertical panel. 20 centimeter are for my structure. I let you more than what I have. I let you 50. But in this box, I give you the amount of sand, this amount, that you have to put it. Then you can move it as you want, but the total weight, we exactly know how much is it. We do that for the vertical panel. You see that the formwork and with the sand, so you can imagine how you can work with that. On these things was the drawing a bit to follow. And you see the elements after, and when you take it out, you just have this shape. The horizontal panel, we do it a bit different because the joint in the floor are not nice. If the people beyond you is cleaning the floor, you don't want to see the water, you don't want to see up. And then we say, okay, we need an extra tools. And so we have the same formwork, with different size, where we just give the amount of sand. Then this is just for the shape. But the structural part, we divide it in two. One was precasted, and the other one was in situ concrete, so that they come together. And then I just start a bit to think about how you use structure. You can use structure and related to the shape. You know, a funicular structure, just show the forces. It's a nice example of Robert Meyer in Chiasso. This amazing roof. You know a bit how it works. This is one arch in compression. And if you just put compression, it just go up. This is a cable, which in the middle, it just receives the vertical force of the arch. And then the funicular just go up and down. Some of the loads go in the center and go down like that. This is structure and shape. Then you know for sure the relationship between structure and space. There are many nice examples. This is one of nice building. This one wall which define the space and carry the loads. This house of Christian Carrets. And they say, let's try with something similar, components and flow of the forces, how forces are working. And then I say, okay, if I put the floor element, I will carry the loads to the wall on the back, this one, and the wall on the front, which is done by panel. You see, a bit of the loads go there, mostly go just there. There you see the panel of the roof. And then I say, okay, we just put the stone on the ground. these are really simple, are stable. And now we continue. We put the floor in top of it. There are some of them which are exactly on one stone, on one panel. These are okay. There are the gray one, which we can believe that they work because they are in balance, almost supported, not continuously supported, but yes, yes, yeah, yes. But the other one, this one, which is flying. Okay, problem. Let's try to put the next layer, and then we see that there are pieces which are giving the loads down. Again, pieces which are a bit imbalanced, but they're still in equilibrium. And there are other pieces that receive a new task. They have to carry the floor, which is above. We have to hanging, and to transform this into a beams. This is standard elements, like this. If you use a violet, you can just try to put a truss, and you just understand that you have to connect it in the top and the bottom in order to transform two pieces into a beams. And you see that this was the standard reinforcement. I just had some connection on the boundary where I welded some piece of steel just to connect this point and this point. And of course, it's not enough to connect the walls. We also have to connect the slab to the walls. You see this piece of steel which is there. We just connected the reinforcement of the floor up to the walls. And so we just can continue step by step, up, up, up. Of course, there is the stability. Same principle. We just connected the element in order to take horizontal forces. This is a bit a study of the forces, how they go by stability. It's a bit late to go through this calculation. And you see the elements, how they are. And this picture, you already see it. This is this wall which gives stability by elements. And you see during the construction, the production of the elements, every one a bit different in place. These are elements of the slab. You see that there is the flat part. Then you see the construction, the in situ concrete and the wall elements, one after the other. And this is the building that is growing. You see this is the precasted floor elements. Then we don't see it, but in the back there is the concrete, in situ concrete, and you see the building at the end of the construction. So now we have to speak about technology and construction, just some remarks. You see that when you speak about prefabrication, you unify a bit the different form of traditional construction, the massif and the dry one. Massif is really nice. You can choose the shape. The dry is really nice by the connection. Technology has something nice because it makes the prefabrication free from the mass production. You know, until today we can say we have to produce many pieces all the same. This is the prefabrication. But with technology we can change the shape of every element, and we saw how nice it is by the Green Calder building, for instance. I mean, we can precast unique elements, and this is something that has a value. You know, to do something that is unique, it makes the construction rich. In this sense, prefabrication opened the dialogue with technology. we can define a new art of work, which is not the handwork, but is a digital work, which we transform into the precast element in something which is unique. What is nice, make people more happy to work on this form. And prefabrication, at the end of the day, you can do everything. It preserves the essence of the construction, what I think is really important. You know, we can feel forces, we can feel balance, geometric richness is not a problem, character of the material, we create stone. The visualization of the construction process, which for me is really important, is there. You can show that, and all kinds of idea. I think going deep into this work, in this prefabrication, this thinking, we preserve and we promote the value of architecture. And this is really important, because if you only build as in the past, we don't get further. We have to make things a bit new, a bit different, and we have to make sure that our work is still nice also in the future. That's it. Thank you. You know, one of the things that is nice in the work of engineering, of architecture, of the construction, is that we build prototype only one time. You know. This is something really rich. It costs a lot of energy. And this is important. Concrete is really robust. You know, concrete is a material of bridge and not of houses. At the end, you can allow pretty many things and it's still robust. You know, concrete wall, you can just clean it, you never get old. Of course, it gets old by chemical transformation over years. So of course, you know, you just make more cover. Today, we know how to build or building in concrete. And for me, it's to speak about problem or durability or of a concrete building. It's a bit funny because, you know, after 50, 70 years, people change opinion and want something new. If we have a building that have this life, it's already enough. I think this building will stay much longer. I think also, you know, one thing, today we have a lot of building, you know. Every building that you have, it's a work to maintain it. This building can be taken apart in elements. You can demolish in a nice form, and maybe you reuse the concrete in a different way. I think this is also nice. If you just do a standard building, what can you do? You make a renovation, or you just broke in it. At the end, I don't think it's a problem.
Have you experienced some problems there?
My buildings are not so old.
Any other questions?
Please.
As an engineer that collaborates with architects and illustrative their traditional role, we architects, when we have to basic projects, we have to type on parameters, take decisions and change things all the time. And structure is not different from this. So would focus, would you recommend us to put in our architectural, our structural approach? So when these decisions come to the project, we as architects always rely too much on different professionals on the building. So we are more aware of this decision making.
You know, the trick, don't stay alone. Just speak and tell what you want to your engineer. Make them friends, because you don't build no things alone. One of the nice, I'm sure you know Maison Floriac, Le Monotti. And if you give a bit a look to the history of this construction, bring colas, phone to Cécile Bayon and say, I have nice things to build. I have to make a villa fly over this situation. And in the first communication about this project, he tell him the dream, the topic of the project. If you know what you want and you tell that clearly, then you open the discussion. And don't do the job alone. That is it's not correct. If you share your ideas, if you understand what you want and you are able to share your idea, then it becomes really nice. It's not a work anymore. It's a research, and all these kind of projects are research at the end, are not standard. We just really enjoy to discover something. We don't know at the beginning which is the solution. If you give a look, I never show the solution at the beginning. I show you a bit the research, and it was quite tough.
Some other questions? Please.
Thank you so much for this incredible lecture. It was a pleasure to look at this symbiotic relationship that you somehow, also now when you speak about this relationship with architects, it's basically, it's your work of art together with another author. What was, I think, what you spoke regarding the last question, I think it was truly important, because these are all extremely specific projects, very classic. So let's say the first question would be from my side, how were you able to work on this unique but radical, extreme, we knew the project, and we knew that there is enormous amount of engineering behind, and there is deep thinking, but how do you forge these relationships to really work on these kind of prototypes, as you say? These are all research projects which are building one-to-one. So how did you manage in your career?
At the end, you have to understand how it works. I think the secret is to be curious, to look at things and to look at opportunity that you receive. You study piece by piece, and when you can explain it how it works, you are sure that you have understand it. And so I work with my friends at the end. When I'm able to understand how the structure works and how we can build it, then I'm sure it works. I just use the architecture as a person that is listen how things are put in together. And if he understands and he agree, then I'm sure that I just have to calculate it, but it will work. And you see that in all the building. At the end, the static is really simple. Things are put it one on top of the other in a really simple way. The interest is just in different elements, it's just in connection, in details. You know, it's something that you have to learn. You choose how difficult the project becomes, and you manage that. You can even say, make it a bit more simple. With the element, we try everything we can. You know, we move some elements just to get rid of some problem. This is something that is up to you. I think sometimes you just you have to pay attention as an architect that you don't define a project or a problem that is too big, that doesn't have a nice solution. And you have to be able to change a bit the rules and listen, what is the problem? Because a complex solution sometimes is just not nice. And for this reason, I just think that there is a lot of work. Also for the people that I spoke to, architect, they just accept. You know, they even go for months looking kitchen with the client. It's something important. You know, you have to understand how you get rid of problem when problem become too much problem, you know. You don't have to solve everything. You have to find out a particular solution. And this make a project.
We've seen a lot of projects out of concrete, which in the last years is somehow becoming the enemy, of sustainability and ecology. But what I think is really unique, and you mentioned it a little bit in the last project, is that if every element is prefabricated, but it has uniqueness in its own, and it can be dismantled, then we can understand this as a circular economy. So that building could be all these elements could basically form something else. But for structural properties, they do need to be maintained. So you truly think that the last building that you showed, that we all know, could be in 50 years put out in pieces and somehow something else could be done.
So for things, concrete received this negative aspect or yeah, no, just it's too much energy, it's not good. But the problem is that we use it too much. We don't spend enough time on the concrete. And the problem is how we use people. You know, it's not, if we just put more work and less material, I think the balance can completely change. I don't think that it's this building that make a problem of the concrete. And I don't think that if we build many buildings like that, which a lot of work and, if you want, a bit of material, but compared to the time that people spend on the building, it's not that much work. You know, if you go and you see a building that grow really fast, we have to spend our time on life by making amazing things. This is the problem of our society. If we just make it a bit more complex, a bit more different, that people find amazing to build building, and not only to live in standard flat. I think it can become, the problem of the concrete is just get a bit a different view. You know, many of the buildings that are in concrete, we can also build it in brick. It's less dramatic. Also, this standard building don't need concrete at all.
Cheaper than building
or
In some countries, very different.
yes, or because people doesn't want to calculate it unit things, prefer to calculate it standard things, prefer to draw standard things, prefer to make quantity and not quality. But that is something that we have, at least in the school, we have to pay attention and to research. You know, just that we don't look at the construction only as the final product, but as a process which involves people, which is part of the society.
Can I also ask one question?
Yes.
Today, in the presentation, we've seen many projects, many different techniques, and through the design process, sometimes you change the design, the initial design. Sometimes you change the material or the way it's crafted. And I was wondering, what for you when you started working on the project or when you work on finishing it, what's the highest goal to make it like as close as possible to architectural concept, to make it as the production of it as efficient as possible? What brings you the biggest, the deepest satisfaction on the work with the work of the project?
To make it simple. To make it simple. You know, when you see that you achieve to make one roof on 2 pillars is an exercise. But if it becomes something simple that you see how you get that, it's amazing. If you want to produce pieces which are unique, how you put it together, and you get into solution that you accept and you think, yes, it works, it's amazing, you know. This is for me the most important thing. I never look if I use concrete, steel, wood. Of course, the opportunity that you have with concrete are much bigger than the one that you have with wood or with steel. You can do light things, but it's not so easy to have this end results, which is really everything's just come together, you know. But at the end, it's important to understand and make it simple. This is fundamental.
That sounds great. Any other questions? Probably someone has.
One short question. Do you also accept less practical, less perfect work as an engineer?
I have some work that I do just for have the money to finance the other one.
So you didn't show this work?
I think there is less interest. You know, of course, there are things that are standard. You don't always look for to have trouble. You can think only one problem at a time. And you need to have the time to think of the project, at this project. Then sometimes you just accept to do standard things, yes.
The serious question is, do you think that your work, this work that you showed, would change the whole practice or influence the practice of prefabrication?
I don't know. I don't care really. But I think I just use the chance that I have by the building to put something that stay and that people can look and think. Because, you know, alone you change no things. But if you put a building, it stay over years. Many people will see that, will making questions. I'm sure with the time you can reach something. And if you achieve to make some questions in the people, it's already a big step.
Any other questions? Well, probably that's the time to say
Stop.
thank you very much for an amazing lecture. One of the key things which you highlighted after showing all these extraordinary projects, how to make it simple. That's, I think, what all of us should bring out of this lecture, how to look at the most complex things in the easiest and the simplest and the most efficient way. Thank you very much. Thank you very much.